Hello students, I am Bharti Shinde working as a lecturer in Praveen Patil Polytechnic College. In this video, we will see the second chapter of Applied Mechanics and its name is Simple Lifting Machines. First, we will see what is machine. So machine is a device which utilizes energy in the available form for doing work. So in this chapter we will see the principles and working of simple lifting machines. So simple lifting machines are classified as simple machine and compound machine. So simple machine is a device which is used in lifting heavy load, and simple lifting machine has only one point for the application of effort and one point for load. Its mechanism is simple. Simple lifting machines are used in lifting load applied at one point by applying comparatively smaller force, and the smaller force is called as effort applied at another point. So in most of the cases P, that is effort. So P is smaller than W, that is W means load and P means effort. So effort is smaller than load, but sometimes it may be greater than load. Then we will see compound machine. So compound machine has more than one point for application of effort and the load. In simple machine, only one point for the application, and in compound machine, more than one point for the application of effort and load. Its mechanism is compounded and complicated as compared to simple machine. And examples of compound machines are planer machines, lathe machine, shaping machine, etc. And examples of simple machines are lever, inclined plane, screw jack, etc. And the compound machines and simple machines have different examples, and we will see the machines. Simple lifting machines examples, or which we are going to study in second chapter, are wheel and axle, Weston's differential pulley block, worm and worm wheel, geared pulley block, screw jack, etc. First of all, we will see basic concepts, that is first load, and it is denoted by W. The resistance to be overcome by a machine or the weight to be lifted is known as load. Load is nothing but the resistance to be overcome by a machine or weight to be lifted. Then second point, effort. Effort is denoted by symbol P. Effort is nothing but force applied to overcome resistance or to lift the load. It is known as effort. Next, mechanical advantage. It is also written in short form as MA. So mechanical advantage is a ratio of load lifted by machine to the effort applied to lift the load. That is, it is a ratio of load to the effort. So MA is equals to W by P. and mechanical advantage has no unit and it is a pure number. And MA, that is mechanical advantage, is almost greater than 1. Next point, velocity ratio. So velocity ratio is a ratio of distance traveled by effort, that is y, distance traveled by effort, which we are going to denote it by y, to the distance traveled by load, that is x. So velocity ratio is a ratio of y upon x. And VR, that is velocity ratio. VR is always constant and it has no unit. Next point is input. So input of machine is a product of effort and distance through which effort moves. That is input is equals to P into Y. Y is distance moved by effort and P is effort. So in short, input is a quantity, that is P into Y, which is applied to the machine. And input is the work done on the machine. The next point, output. So output of machine is a product of load W and the distance through which the load moves, that is X. So W into X. W is load and X is distance moved by the load. In short, output is a quantity which is derived from machine and it is work done by the machine. Input is work done on the machine and output is work done by the machine, which is a product of W into X. Next, efficiency. So efficiency is a ratio of output to the input of a machine. And efficiency is generally expressed in percentage. So percentage efficiency, this is the symbol for efficiency. This is the symbol for efficiency. So percentage efficiency we can write output divided by input multiplied by 100. If we want efficiency in percentage, then you have to multiply it by 100. The efficiency of machine can be defined as the ratio of mechanical advantage to the velocity ratio. So efficiency is nothing but MA divided by VR. And if we want efficiency in percentage, then multiply that ratio by 100. And efficiency is always expressed in percentage, remember. Next point, ideal machine. The ideal machine is the type of machine whose efficiency is 100% and in which friction is zero. So the machine whose efficiency is 100%, we called it as ideal machine. And this machine is absolutely free from frictional loss or from friction. Then we see characteristics of ideal machine. So first characteristics, output is equals to input. Because for ideal machine frictional loss 0, so input minus output is equals to 0. If we take input minus output is equals to 0, then input is equals to output. Then efficiency of machine is 100%. But in practice, it is not possible to eliminate friction. So frictional resistance exists or frictional loss exists. Therefore, as we know, efficiency of machine is always less than 100%. The next characteristics, machine is free from frictional loss and mechanical advantage is equals to velocity ratio. Then next term we will see ideal effort, that is PI. So ideal effort is the effort required to lift the load when there is no friction in the machine. So if there is no friction, then machine is ideal. So MA is equals to VR. Then MA is nothing but W upon PI. As we have seen, MA is nothing but W upon PI. So W upon PI is equals to VR. So PI, that is ideal effort, is equals to W upon VR. So MA is equals to VR. We can write MA is equals to VR. Then we know MA is nothing but W upon PI. So PI is nothing but W upon VR. Then next term, effort lost in friction. So effort lost in friction is the additional effort required to overcome the friction, and effort lost in friction is denoted by PF, and its formula is P minus W upon VR. Then next term, ideal load. So ideal load that can be lifted by given machine when there is no friction in the machine, and ideal load is denoted by Wi, and its formula is P into VR. So the product P into VR is called as ideal load. Next term, load lost in friction, and it is denoted by WF, and is defined as the difference between ideal load and actual load. So mathematically we can show it as load lost in friction is WF is equals to P product of P into VR minus W. Next we will see law of machine and its significance. So the relationship between load lifted W and effort applied P is known as law of machine. Relationship when plotted on a graph results in a straight line as shown in below. This C distance and then there is a inclined straight line. And the equation of the straight line is P is equals to mw plus c in Newton. So in that equation, P is nothing but effort required to lift the load. M is the slope of line. W is load lifted by the machine, and C is intercept on y-axis, that is nothing but effort required to start the machine. Now, what is the importance of law of machine? To see that law of machine is important because using law of machine we can find effort required for certain load or load that can be lifted with given effort. So in this way we can find effort as well as load. Then significance of law of machine. So law of machine gives idea about load and effort relationship. It also tells us about friction present in the machine under no load condition. Law of machine can be used to find load when effort is known and can be used to find effort when load is known. And also we can find maximum mechanical advantage. So what is maximum mechanical advantage? So mechanical advantage of machine when friction is not present in the machine is called as maximum MA or maximum mechanical advantage, and its formula is 1 upon M. 1 upon M. In which M is slope of line or is a constant. Then we will see concept reversible machine. A lifting machine in which load starts moving back to its original position when effort is removed is called as reversible machine. So reversible machine is a machine in which load starts moving back to its original position when effort is removed. Such a machine has efficiency more than 50%. Then we will see non-reversible, and it is also called as self-locking machine. So a lifting machine in which load remains at its position even when effort is removed is called as self-locking machine or non-reversible machine, and its efficiency is less than 50%. So the efficiency of reversible machine is greater than or more than 50%, and efficiency of self-locking or non-reversible machine is less than 50%. Then we will see condition for reversibility of machine. So when efficiency is greater than 50%, then machine is reversible. When efficiency is less than 50%, then machine is irreversible, or it is also called as non-reversible or self-locking machine. And when efficiency is 50%, then machine is on the point of reversing. These are the different formulas for different machines. So for screw jack, VR, that is velocity ratio, formula is 2 pi L divided by PT. For Weston's differential pulley block, VR is 2D upon D minus D, capital D minus small d. For differential wheel and axle, velocity ratio is 2 capital D divided by D1 minus D2. For single purchase scrap, VR is L upon R into N1 upon N2. For geared pulley block, VR is N1 upon N2 into N3 upon N4. For double purchase scrap, VR is L upon R into N1 by N2 into N3 upon N4. For worm and worm wheel, velocity ratio is capital RT divided by NR. And for simple wheel and axle, VR is capital D upon small d. Now we will take one example. For a certain machine, VR is 125. To lift a load of 11.90 kN, an effort of 190 Newton is required. Calculate effort required to lift a load of 72 kN and identify the type of motion. First of all, write down all the given things, that is VR is 125, load is given as 11.90 kN, that is W, convert it into Newton, and effort of 190 Newton is required, which is P. So calculate effort required to lift a load of 72 kN and identify type of machine. First of all, we will find MA, that is W upon P. And after putting the values in calculator, we will get 62.63. Then find efficiency, which is MA upon VR into 100, that is in percentage. After putting the values, we will get efficiency 50.10%. And as we know, efficiency is greater than 50%, then the machine is reversible. So here we got reversible machine. Then we have to find effort required to lift a load of 72 kN. For this, as we know efficiency, we can find P by putting this formula MA upon VR into 100. So as we know, MA is nothing but W by P. So W by P upon VR into 100. And after putting the values and by cross multiplication, we will get effort, that is P as 1149.70 Newton. In this way, you can solve various numericals by changing the values. Then we will see example 2. In a worm and worm wheel, number of teeth on worm wheel is 120 and diameter of effort wheel is 100 mm and that of loading drum is 150 mm. This worm and worm wheel lifts a load of 2.5 kN by applying 100 Newton effort. Calculate efficiency and effort lost in friction. So this is the example of worm and worm wheel. So apply the formula which are given for worm and worm wheel. So number of teeth on worm wheel, which is given as 120. Then radius of effort wheel, which is diameter by 2. It is 100 by 2, 50. Then radius of load drum, as diameter is given as 150 here, we can find radius 150 divided by 2, which is 75 mm. And we have to find efficiency and effort lost in friction. So for finding efficiency, use same formula MA upon VR into 100. So for this, first find MA. So MA is nothing but it is mechanical advantage and its formula W upon P. So after putting the values, we will get MA as 25 and velocity ratio is RT divided by small r, and which is 80. By putting MA and VR value in efficiency equation, we will get efficiency 31.25%. So we have found out efficiency. Now find effort lost in friction. So for this, write formula PF is equals to P minus PI, which is the formula for effort lost in friction. So P minus PI. So P minus PI के write the value formula of PI, that is W upon VR. Then PF is nothing but P minus W upon VR. After putting the values, we will get PF is equals to 68.75 Newton. Next, we will take example. A machine lifts a load of 19 kilonewton and 29 kilonewton by efforts of 700 Newton and 900 Newton. Calculate law of machine and efficiency of load of 50 kilonewton if VR is 50. So, two loads are given, 19 kilonewton and 29 kilonewton, and two efforts are given, 700 Newton and 900 Newton. We have to find law of motion and efficiency of load of 50 kilonewton if VR is 50. So first of all, apply law of motion, that is P equals to mw plus c. So m and c keep as it is and write down the values for P and W. So for 19 kilonewton load, effort is given as 700, and for 29 kilonewton load, effort is given as 900. So when we get these two equations, then subtract equation 1 from 2, then we will get m is equals to 0.02. For finding c, put m is equals to 0.02 in any one of the equation, and we will get c is nothing but 320 Newton. And as we got m and c, so write down law of motion, that is P equals to mw plus c, in which put the values for m and c. So this is m and this is c. Then second we have to find efficiency of machine. So for this efficiency formula, that is Ma upon Vr into 100. So Ma is nothing but W by P. For this, we have to find P, and for finding P, W is given as 50 kilonewton. So put that in P equals to mw plus c equation. As we know, m equals to 0.02, W 50 kilonewton, C 320. Then we have found out P, that is effort, 1320 Newton. Then put that value in efficiency equation, that is W by P upon VR into 100. So 50 kilonewton divided by P 1320 divided by VR, that is VR is also given as 50, multiplied by 100. So after solving on calculator, we will get efficiency as 75.76%. Thank you.